Welcome to the solutions to the momentum problem set, problems number 10 and 11. Let's get started with number 10. A 7-gram bullet is fired into a 1.5 kilogram ballistics pendulum. The bullet emerges from the block with a speed of 200 meters per second, and the block rises to a maximum height of 12 centimeters. Find the initial speed of the bullet. Ballistics pendulum is a very common way to determine velocities of bullets fired from guns. Commonly, the bullet sticks inside the pendulum, then causes the pendulum to rise to a certain height. By knowing that height, we can find the velocity that the pendulum started out at the bottom, and then work backwards to conserve momentum and find the velocity of the bullet as it was fired from the gun. In this particular case, the bullet emerges from the block, and we'll take that into consideration when we conserve momentum at the end. But as I just mentioned, we need to work backwards in this problem. We're going to use the height to find the velocity of the pendulum at the bottom, and then we're going to conserve momentum of the original event to find the velocity of the bullet initially. To find the velocity of the pendulum itself at the bottom, we are going to conserve energy to do that, mechanical energy. In the initial state, the mechanical energy of the block would be kinetic. And as it rises and comes to rest, it gains gravitational potential energy in the final state. So our conservation of mechanical energy statement becomes 1/2 mvo squared equals mgh. We see that m cancels, therefore we don't even need to know the mass of the pendulum. Substituting in that we know that the block rose 12 centimeters, which is 0.12 meters, we can go ahead and solve for the initial velocity of the block after the bullet passed through it to be 1.534 meters per second. Notice we're taking now extra digits there to not sig fig on our answer. Now that we know the velocity of the block after the bullet passed through it, we can now go ahead and conserve momentum. So we start with our conservation of a momentum statement. P before equals P after. What objects, if any, have momentum before they meet? And the answer is only the bullet. And so we see our bullet of 7 grams times its initial velocity, VO, which is what we're looking for, after both the bullet and the block have momentum separately. And we know that the 7-gram bullet reached a speed of 200 meters per second, and that our 1,500 gram or 1.5 kilograms converted to grams to stay consistent with our mass units, reached a velocity of 1.534 as calculated in the previous conservation of energy solution. We go ahead and solve for the velocity of the bullet, and we get 530 meters per second. If you have any questions on this approach, make sure you ask in class tomorrow before we proceed with the last problem. All right, let's move on to number 11. Really neat AP physics question. Let's take a look first and then we'll talk about it. An 8-gram bullet is fired into a 250-gram block that is initially at rest on the edge of a table of height 1 meter. The bullet remains in the block, and after the impact, the block lands 2 meters from the bottom of the table, as shown in the diagram below. Determine the initial speed of the bullet. Okay, in this case, it looks like we're going to have a conservation of momentum question, and just by the diagram alone, we see that it's probably being combined with the projectile motion concept. The 2 meters from the edge of the table, as labeled in the diagram, would be the range, XX. And the 1 meter labeled as the height of the table would be our xy value. In order to conserve momentum and find the initial velocity of the bullet, we need to know the speed with which the block left the table. The speed with which the block left the table can be solved using projectile motion concepts, and then we conserve momentum to find the initial velocity of the bullet. Once again, in this problem, we're working backwards to find our answer. We're working from the end of the event back to the beginning of the event. The issue we have in finding the velocity with which it leaves the table, and it's a horizontal velocity, is that we don't know the time it takes the block to reach the floor. However, they gave us the height, so we can use the vertical motion to find the time in the air, and then the horizontal motion to find the velocity it left the table with. So we start with our vertical equation in projectile motion. Xy equals VOYT plus 1/2 GT squared. 1 meter is our xy value. There is no initial velocity vertically because it leaves the table horizontally. So our VOYT term is 0 plus 1/2 9.8 t squared. We don't have any conflicting directions here. The 1 meter is down, the 9.8 is down. So we can go ahead and just solve for t to be 0.4518 seconds. Now that we know that, we can solve using the horizontal equation. Vx equals xx over t. Our range is 2 meters. Our time we just saw, 0.4518 seconds. And our horizontal velocity is 4.427 meters per second. Now we can go ahead and do that, use that to conserve momentum and find the initial velocity of the bullet. P before equals P after. What objects, if any, have momentum before the collision? That would be just the 8-gram bullet. So our initial momentum, our P before, is 8 times VO. For our P after, the bullet sticks inside the block for a total combined mass of 250 plus 8, which is 258 grams, times the velocity 4.427 meters per second that we just solved for using projectile motion concepts. Go ahead and solve for VO, and we find the initial velocity of the bullet to be 143 meters per second. Once again, if you have any questions about any of the concepts that have been shown here or any of the solutions that have been shown here, make sure you ask in class tomorrow before we proceed with the culminating problem of the entire unit, problem number 12 in class.